Hello everybody, Marie here with the McWane Science Center. Welcome to another Sci Sparks. Today, we're going to be experimenting with pH in a very colorful way. Today we're going to be talking about pH, or how acidic/basic different substances are. pH is, most technically, the number of H+ or hydrogen ions in a solution. The more H+ ions there are, the more acidic a substance is. Now, ions are created when atoms gain or lose electrons. When an atom gains electrons, it gains negative charges and thus becomes a negatively charged ion. When an atom loses electrons, it loses negative charges and thus becomes a positively charged ion. Now, how do we determine the pH of a substance? How do we determine whether something is acidic or basic? We use indicators. We could use phenolphthalein, which turns pink in the presence of a base and clear in the presence of an acid. We could use red cabbage juice indicator, which turns a range of different colors in response to different pHs. Or we could use what we're going to use today, universal indicator, which also turns a range of colors in response to different pHs. But these three different indicators are just scratching the surface of all the indicators that are out there. Here in front of me, I have a beaker half full with water, milk of magnesia, universal indicator, and vinegar. First, I'm going to add a dose of milk of magnesia to my water. And then I'm going to give it a stir to get a nicely consistent milky color. Now we need to figure out what the pH of the milk of magnesia is. So we're going to add just a little bit of universal indicator. What color do you see? That's right, it's purple. And if we look at our pH indicator chart, we'll see that this color lines up pretty well with a 10.5 pH. Now it's time to set up our rainbow reaction. We're going to add a little bit of vinegar to our solution. What color do we see now? It's a bit of a reddish-orange color, which means it's about a 2 on the pH scale, which is quite acidic. Wow, we just went through a bunch of different colors. If you refer back to our pH chart, you'll see that we went from very acidic to slightly acidic to neutral to slightly basic and back to medium basic. This is because the milk of magnesia and vinegar ions are complementary. Milk of magnesia has many more OH negative or hydroxide ions, and vinegar has many more H+ or hydrogen ions. Because these ions have opposite charges, they can come together to form H2O, or water, which reduces the overall basicity of the solution. Now let's add some more vinegar and see if we can get the same reaction. Now that our solution is a translucent red color, all of the vinegar that can be used up by the milk of magnesia has been used up and has been converted into water. But all of the excess vinegar makes our final solution quite acidic. That's it for today, but you can try this at home using red cabbage juice as a pH indicator. Thank you so much for joining us today. Be sure to like, subscribe, and comment down below. And see you next time on Sci Sparks.